The longest common subsequence problem can also be solved using recursion. Let's see how. To solve the longest common subsequence problem using recursion, what we need is a recursive definition. And here's the recursive definition for the longest common subsequence problem. Say that Cij represents the longest common subsequence length so far. So length of the LCS between Xi and Yj. So if we have two sequences S1 and S2, then Cij represents the longest common subsequence between the ith, between the subsequence up to the position ith in the first sequence and up to the position jth in the second sequence. So obviously, if I equals to 0 or j equals to 0, then Cij will be 0. If xi equals yj, say for example, at one point, let's say xi equals yj, so here's my xi and here's my yj. If they're equal, then we say that the length of the longest common subsequence now will be the length of the longest common subsequence up to I minus 1 and j minus 1 plus 1. In other words, the longest common subsequence up to this position I and this position j is 1, because here we have a match, plus whatever the length of the longest common subsequence we had up to this point. So that's pretty straightforward. Now, when we have xi is not equals to yj, say for example, we're at a point where maybe I is over here where we have t, and then say j is somewhere over here where we have a as j. So clearly xi is not equals to yj. So xi is t and yj is a, and they are not equal. In this case, the length of the longest common subsequence will be equal to maximum of two possible longest common subsequences. One is the longest common subsequence between I and j minus 1. So we keep this subsequence as it is up to I, and we take the subsequence of this up to j minus 1. And whatever the longest common subsequence between these two is, we put it over here. That becomes our first choice. And the second choice is the longest common subsequence between my entire sequence up to j and this one up to I minus 1. So this gives us a recursive way to calculate the longest common subsequence for two sequences of lengths I and j, because here you see that Cij depends on Ci minus 1, j minus 1, one dependency. This also depends on Ci, j minus 1, and also depends on Ci minus 1, Cj. Now, obviously, recursive solution is going to take a lot of time, and it's going to be extremely slow. Now, let us see if the optimal substructure property discussed in the dynamic programming algorithm applies to the LCS problem. Because if it does, then we can go ahead and apply dynamic programming.